Hello everyone. Now today we are going to see the numericals on Spur gear. So here is the problem statement. Here two involute gears, they are in meshing with each other and the pressure angle is given as 20 degree. The number of teeth on pinion is 20 and the gear ratio is given as 2. So from the gear ratio we can directly get the number of teeth on wheel. Module is given as 5 mm and the sliding velocity is 1.2 meter per second. And addendum is standard, that is 1 m, so it will be equal to 5 times of m, that is 5 mm. So first of all, if here we are knowing from the gear ratio, we are knowing the value of number of teeth on wheel and number of teeth on pinion is given as 20. So directly we are getting the value of pitch circle radius for pinion and gear. So for pitch circle radius it is given as module into number of teeth on pinion divided by 2, and for the pitch circle radius of wheel it is module into number of teeth on gear divided by 2. So here after getting the pitch circle radius, the radius for addendum for the pinion and wheel is summation of addendum plus pitch circle radius for pinion and addendum and pitch circle radius for gear. So after that, we know that length of path of approach means the total length of path of contact is summation of path of approach plus path of recess. So this is the formula for finding the path of approach. By putting the respective values, here we will get directly the path of approach. And this is the formula for path of recess as under root of addendum radius of pinion square minus pitch radius of pinion into cos square phi minus r into sin phi. So by this formula we will getting the path of recess. By summation of path of approach and by path of recess, directly we will get the total length of path of contact. Then afterwards, by knowing the length of path of contact, we will be getting the length of arc of contact. So length of arc of contact, it is defined as the ratio of length of path of contact divided by cos phi. So this is the length of arc of contact. Then we will also getting from length of arc of contact the angle turn by the pinion or the gear. So for finding the angle turn by the pinion, this is the formula, that is length of arc of contact into 360 degree divided by circumference of pinion. So directly we will get this value. And for finding the maximum sliding velocity, so it will be given as you know omega 1 and omega 2 are the corresponding angular speed of pinion and wheel. So that by this formula of sliding velocity, we will get directly the maximum velocity of sliding between a gear pair. Then next problem, in this problem, for finding the minimum number of teeth are required on the pinion so as to avoid the interference. Interference means what? If the addendum of the gear or the pinion, if it is entering into the base circle of either of the gear, then it will try to remove the material. So that phenomena is called as the undercutting phenomena, and that will lead to interference. So in this problem, if you see, a wheel is given a gear ratio of 3:1. 3 is the gear ratio, and pressure angle is 20 degree with module as 1. And here the addendum coefficient is for the wheel is taking as 1 module. So in order to find the minimum number of teeth on pinion, this is the formula, and by this formula we can calculate the number of teeth required to avoid the interference. And these are the minimum number of teeth for equal wheel, means these are the gear. For this wheel, it is ratio is given 3:1 means 3. For this will be the value, and for minimum number of teeth, when both of them they are equal, then this formula is used to find the number of teeth on the pinion so as to avoid the interference. Thank you.